So that's it. So if at this point, if you have received 8 out of 10 points, then you will wait that some of the instructors will go and check the final problem. If you have received less, don't worry. We will anyway then check what was the issue of not, or the reason for not getting full points. Yes, so I could also then show, related to this, I have now my exercise 2 open in Jupyter Notebook in here, and I'll go ahead and show part of the solution. I hope this doesn't spoil the fun for anybody watching. So in part 1, we had to make these lists, and then we had these visible tests also to help you to understand if you're proceeding correctly. So if I would now run this code in here, you can see that these assertions don't raise any errors. So everything is fine, and as you saw, I got full points. But then, for example, one case could be that I maybe did everything correctly, but then I had these years also as string variables. This is kind of logically, this is all right, and I think we haven't specified that they should be integers, but now if I run this cell which tests if the first item in the station start years list is equal to 2003 integer value, then you can see that I get an error, and this will then also cause the grader bot to fail part of this submission. So in a way, this is not such a big mistake, but things like this will then cause errors. And these visible tests, you can see that there's some true or false statements. So this is either true or false based on your input. And then we have also additional hidden tests that will then define the final point. Okay, so I think we didn't before. We will discuss these assertions more in detail later in the course, but these visible tests are there to help you to kind of figure out the correct answer. So that was one of the points I wanted to raise, and I'm now pressing Ctrl check to kind of revert to the correct solution. And then another point, just kind of for technical reasons. So if I would, sometimes you might want to add additional code cells to your notebook file. And there's different ways of doing that. So for example, after this first cell, I might want to print out my lists to see the values. So there is this little plus button at the top. So if I'm now this cell is active, and then I press the plus button, I'm able to create a new cell, and then I can check the value of these variables. So some of you had been in a clever way, copy pasting these cells, but we would encourage you not to copy paste existing cells, because then the system we are using, the NV grader, has some hidden information, for example, in these test code cells, and then that might also cause some additional problems with the grading, which is a bit unfortunate. So in some, if you create new cells, use this little plus button here at the top. That's it. Remember to comment your code, all these basic good coding practices that we have been doing so far. And those are then the things that the instructors and your partner will check along the way. So if you have any questions related to this, I'm happy to answer. Maybe we also wanted to know with Dave, we know that the flag exercise is a bit challenging but fun in exercise 3. So maybe we could at this point use the little green check marks if you would like us to spend some time showing the solution to this exercise.
Here I have my Jupyter notebook, so I'm open this up on the CSC. I need to first quickly go here to exercise number 2. And I'm just going to go to the version of the exercise that's public. Take a look at our exercise number 2 notebook and just scroll down to the flag exercise problem because I don't remember
That's
exercise number 3.
Yeah, sorry, I was jumping ahead.
No, it's my let's see here. There we go. Let's do exercise number 3, problem 4. So here we have this flag, and I'm just going to maybe copy this so that I can have an example here. Oops. So our goal is to reproduce a flag pattern like this. And we can do this a number of different ways. In fact, I think the approach to how you solve the problem, it's somewhat open-ended. But at least in this case, the first thing I look at when I see this general structure here is that we have a pattern of a certain number of stars and a certain number of dashes. And we have this sort of regular geometry in the sense that there's 5 lines. And I think in total, there's something like 20 characters across the length of this line. So I think there's 7 stars, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, maybe it's 19 with the number of dashes included there. So if there's 7 stars and then 12 dashes here, what it means to me is I sort of look at this and I say, okay, well, we have the pattern of something that is 19 columns or 19 characters across and 5 lines long. And automatically I sort of think then, all right, well, that means we can use some kind of for loop to reproduce this pattern. And without having thought about this in advance, my approach here would probably be to start with some for loop here that's going to go through, for instance, first the number of lines that we have. So for, I guess we could say for a line in range 5. So this is going to give me the 5 iterations that I would need to print something out on different lines. And just to test things out right now, I could say, run this and I would get 5 lines of output this way. So just by going through here and having a print statement 5 times, I get my 5 lines of output there. Now, as mentioned, there's a number of different ways you can solve this kind of problem. So let's go back here to our 5 lines. One possibility would be to go character by character on each one of the lines and check and say, okay, which position am I in? Should this be a star or should it be a dash? Or we could do something where we take advantage of the kind of multiplication of characters when generating strings of characters in Python. And in my view, maybe that's the sort of simplest option because basically the first 3 lines look the same and the last 2 lines look the same. So in this way, I could have my for loop and just have one statement that says, if I'm on this line, print this. If I'm on the other line where it should be all dashes, print that. So here I could say for my 5 lines, if line is less than 3, so in this case, that's going to be meaning that it's line 0, 1, or 2, which would be 0, 1, 2. We're going to print one thing. And in this case, I'm going to print. And what I'm going to do here, and again, there's multiple ways to do this, is I'm just recognizing that we have 7 stars and then 12 dashes. So I'm going to print 7 times the star character, and I'll just plus 12 times the dash character. Now that should give me 7 stars in a row, and then add to those 7 stars 12 dashes in a row after that. That's only if I'm on the first 3 lines. Otherwise, I'm just going to print 19 dashes. Now, I can add some comments in here, like print a line with 7 stars and 12 dashes, and then print a line with 19 dashes. So if I run this now, I think I should generate a pattern that looks basically like our expected pattern here. I think the number of dashes and things like that should be okay. And as mentioned, I mean, to me, this is the simplest way to do it just because you have lines that look similar. If every line looked different, maybe you would want to handle things differently. But the other thing that's nice about doing it in this sort of relatively simple way with just multiplying the character a certain number of times is that if we wanted to copy this, for instance here, and make a bigger flag, so let's say we wanted to make a flag that had, I don't know, like about 20 stars and 50 dashes. So combined, that's a total of 70 characters. We can make a bigger flag this way, and we could also make more lines if we wanted to, because the flag now looks like it's kind of distorted. So let's make our flag like 15 lines long, and maybe if we're less than line 9 or something like that, we'll do stars. So you can kind of play around with scaling up the size of your flag pretty easily with this format. And there's a question here in chat about why did it recognize that line less than 3 included the third line rather than less than or equals to? Yeah, that's because line is using the range function. So the first 3 values from the range function will be 0, 1, and 2. So that's going to give me basically 3 lines, which is why I could say line less than 3. It's the sort of frustrating thing about the indexing starting at 0 is it's sometimes looks a little bit weird. But yeah, I don't know if there are any other questions about this. I mean, that's just a kind of quick example of one possible solution. You know, you could do like another for loop with other conditional statements that are mixed in there. There's a number of different ways you can approach this problem. Are there any questions at this point? Or Volko, do you have any other comments about this?
Yeah, it was a good reminder about the indexing starting at 0. So thanks, Diogo, for asking.
Good reminder indeed, yes.
Yeah. And maybe just to sum up, so the deadline for exercise 3 was today, and we will then provide the feedback afterwards. Of course, you'll first receive feedback for exercise 2. So just wait for it.
Yeah, and I think the idea is that we're trying to get you feedback by the start of the next lesson, and things should be a bit smoother now that we have our grading system working a little bit more, well, working, period. And we'll try to get you feedback for exercise number 3 within the next week so that you have that by the time we start the next class.
Dave, there was still a question about putting all this flag thing into a variable as it was required in the exercise. So maybe you can still quickly add that.
Oh, yeah. So, yeah, I mean, that's a good point. So all I've done here is I've printed out this, this pattern like this. But yes, if we wanted to make this into a variable, where we could print this single variable out and get this flag pattern, then what we need to do is first create some kind of empty character string. So for instance, here in our, before we start our for loop, actually, we could make a variable here called flag and just set it equal to be an empty character string. Then what we would do is for each line that we have here, we would simply, instead of printing it to the screen, add that line to the current value that we have in our variable called flag. So I'll keep this here as it is for the moment with printing the flag, but just what we could say is that flag equals flag plus, now we have this pattern here. So we're going to take what we have in flag and we're going to add this piece here, 7 times star plus 12 times dash. That's fine, but the thing you don't know, or well, maybe you do know, but is kind of hidden from us here, is that when we used the print statement to print our flag before, it automatically added an additional character at the end of the line. And that additional character is the new line character that basically prints out and breaks the line at the end so that when we start the next print statement, it starts on a separate line. When we do this adding things to the variable called flag, we do then also need to include this new line character manually in our string that we're generating here. And so after our last dash, we would then have to add in this \n as the new line character at the end of this line. So this will still go through here now 3 times, and it will add to our variable flag each one of these lines with the new line character at the end of it. And similarly, we would need to do the same thing down here. So we could say flag equals flag plus, and we just copy this thing here. We have 19 times dash plus the /n. I don't actually think these parentheses are needed here, so I'm just going to delete them because it should be that the multiplication happens first and then the addition, so that we don't need parentheses here. Now, if we've done things this way, then at the end of our little code cell here, we want to then print out what flag contains. And I will then just comment out these print statements that are in here right now. Now, if I run this, hopefully you can see that what we're going to do is basically just add a line as a character string to each time we pass through our for loop here. And depending on the conditional statement, we'll either add 7 stars, 12 dashes, and a new line character, or 19 dashes and a new line character. If all has gone well, we run this, and when we print that out, we see the same flag pattern that we saw previously. There is an additional space here because the new line character was added to the end of our print statement. And so that's why you get 2, like, 1 extra space here. If you were really being, particular and didn't want that extra space, this new line parameter, you can set equal to just be an empty string. And if we run that, oops, it's not new line. Is it called EOL or something like that? End of line, no. What is it called? All right, this is going nicely. Let's check help on our print command here. End is what you can do to specify what character you want at the end of the line. So here I'm just going to say end equals just an empty character string, which means that it won't automatically add this extra character string at the end of the line. And this is probably not necessary for you to know how to use this end thing, but it does come in handy, for instance, when you want to have print statements that don't automatically have an end like a new line at the end of the print statement. So like if you want to print out, in a for loop, like adding a dot to the end of the line every time that you're doing like an iteration through your for loop to kind of show the idea of like, okay, something is happening. I'm processing some code. Then you can do it that way. Or if you want to print something, like starting to do this, and then you have no end character there, and then you could have another print statement that says done, then it will add it to the end of the line. So that's kind of a useful thing to be able to do when you want to format your output a little bit. What would it do without the new line character at the end is one of the questions here in chat. Yeah, okay, good question. We could do that. What it's going to do is it's basically going to make one long line. So if we do things like this, just without our new line characters in the statement here where we're printing out the flag and run this, we get the same characters printed to the screen, but there's no end of the line. So it doesn't break it up into make 5 separate lines. It just makes one line that has whatever 5 times 19 is. I don't know that one off the top of my head, but you can see then one line where here we would expect, where my mouse cursor is, to have had the line break to make the second row of stars and dashes for our flag pattern. So if I just undo this change again and run it, those new line characters are basically just breaking so that when we print the next line, it goes onto a separate line rather than just a continuation. So, good question. Anything else about this flag exercise for the moment? Sorry if I went a little bit quickly. I don't know if that's was too fast or was okay, but hopefully you kind of saw the picture. And what you'll start to experience, I think, as you go through getting more experience with Python, is you'll start to look at things. And for me, I looked at this right away and I said, oh, what I see here is 5 lines, 3 that look the same, 2 that look different. And I just said, okay, I could do that with a for loop over the 5 lines and 1 conditional statement to check and see which line I'm on. You'll gain experience with doing these things where you'll start to kind of pick apart the problem and come up with your solution based on what you've learned from some of the earlier exercises, and just getting more familiar with how things work in Python. Another question here in chat about the why isn't there parentheses around the value of the variable flag? Yeah, so kind of a question about the rules here. Is the question just to clarify about like parentheses around this piece here, or is it somewhere else that you're wondering about the parentheses? Yes, okay. So the question's about why aren't there parentheses here? So strictly speaking, you could include parentheses here. We don't have any operations in what's being added to the flag string here that could possibly cause trouble, I think. So Python will follow the normal order of operations in terms of how it does math. So for me, that's going to be this kind of approach where anything in parentheses or any exponentiation, anything raised to a power, that happens first. Anything that involves multiplication or division will happen next, and then anything that involves addition will happen after that. So in this case, what we see is that we're going to get flag plus 7 times stars, so that's going to happen. Then 12 times dashes is going to happen. Those then will, like all of the additions will then happen after that. So in essence, we don't need parentheses here. We could include them. And perhaps, you might want to do that just because you say, okay, well, this stuff is what was in flag before, and I just want to separate out visually what is being added. Because, as it's written right here, especially with having characters like this star and the dash as character string things, I mean, this looks like kind of cryptic with the way it's written here. So putting it in parentheses might just be visually a little bit more appealing. And if you run this, you get the same output that you had before, because all the stuff that's going to happen within the parentheses, this all gets calculated first and then gets added as a single piece to flag. Whereas I think otherwise the multiplication would happen and then you would add the 3 or 4 pieces together. But it doesn't really make a difference in this case because there's nothing that we're doing that could be problematic in terms of like, you know, dividing some piece of or some group of numbers or something like that. Can you put the whole value of flag in parentheses? So like this, you could also do, that would be fine. And essentially this is working just like math. So in the cases where you don't need parentheses, there's no harm in including them in this expression. So yes, you could put this entire thing in parentheses and that would be fine. I don't think there are, I mean, you could, you know, depending on how you want to break things up, you could also do it like this, that you put the piece of where you're doing multiplication of some string parts in parentheses, and that's also fine too. And you can mix how you do it between the different parts. It's all basically kind of treated like mathematical operations in terms of what's happening here. So how you distribute your parentheses is sort of up to you. In some ways, I actually think this looks kind of visually a bit nicer. So it's somewhat subjective. I don't think like the PEP 8 guidelines get into the level of detail of telling you how to use parentheses in mathematical expressions. Maybe there's something in there about that. Like they definitely say something about the white space, but in some ways this actually looks a little bit nicer that you've grouped together 7 times star. So it's clear that there's going to be a group of these star characters and then a group of dash characters. So maybe you would want to do something like that, but strictly speaking, it's not required.
Maybe if they increase code readability, if it makes it easier to understand, then put them in, but they're not needed. So there's no strict rule.
Yeah, that's a good point. And I think, you know, in this case, I would argue that maybe this format actually does increase readability a little bit. So that could be a good reason to use it. Any other questions? Okay, if not, I do think it's probably wise that we move forward with our functions lesson, because I would be happy to go through all the different permutations of how we could solve this flag problem. In fact, in the course in the past, I think we showed 2 or 3 different solutions, but it does chew up a bit of time. So it's probably wise that we move on at this point. And what I'm going to do here is just go back to the course page just to remind you of where we are. So we're here in week number 4, learning about functions. And in our lesson this week, that's going to be the main thing we focus on. We'll also talk about modules a little bit, which are basically just a Python file that contains a group of functions. It's a way to put related functions together. And sometimes can also be referred to as a library, depending on how many functions are present. And the library might be multiple of these module files. But we're going to go through using functions and the idea of functions, because this is one of the things that's probably most useful as a programming concept when learning to code, not only in Python, but kind of any programming language. And we've already started using functions, but this week what we're going to do that's different is create our own functions. So I'm going to go here to the lesson for today. You should see one small difference here. So I think probably most everybody's using the CSC notebook. So if you haven't already, you can click this button to launch your CSC notebook instance. But I've also added an option for launching Binder here that would use the student notebook. So this is the one that doesn't contain the output from the cells or the what you should type in already. So like if you launch Binder from the web page right now, you go like this, you'll see that like already the cells are filled in, So if you want to follow along using Binder, you could do that, and this Binder button will launch the version of the notebook that doesn't have things already filled in, so that you can type them in as you go along in the lesson. Just something to note. But yes, since we want to go live with this, I'm going to go here now back to my Jupyter notebook in the CSC Notebooks platform, going here to the Notebooks folder and then into L4 for lesson number 4, and finally to the Functions notebook. So that's where we're going to continue, and things basically look like they do on the web page, more or less. So yeah, what is a function? Well, that's the first place we can start. And basically, how you could think about this, or how we tend to think about it, is it's a block of code, and it's meant to be something that's reusable and performs normally one kind of dedicated task. The idea in using functions is that you can make your code easier to read and understand by defining these functions that will do certain tasks. And those tasks, especially if you need to repeat them in your code, can be simplified so that you're not copy pasting 10 lines of code to do something a second time, but instead you have one call to your function that shows up on one line, and it makes it much easier to see from that one line, oh, okay, this is just using the function that we have defined to do some temperature conversion or something like that. So we've been using things like the print function already. So functions, the idea is relatively clear. And of course, thinking about the print function by itself, it's also a good example of what a function should do. The print function has a very clear definition. It does one thing, and that is it prints things out to the screen. So you can think about this when you make your functions. If you have a function, you say like, this is my exercise 4 function, and it does everything in the exercise in one function. That's a nice idea, but it's not really the intention of what a function should do. A function should do single tasks, not a whole bunch of things. Sometimes your single task may involve multiple steps, but you should try to think about it when you can to try and get the function as simple as possible to do one thing. And this supports the idea of making the code readable, but also not repeating yourself. So that's another part of the functions, is to not copy paste blocks of code, but instead define something once and then reuse the function call as the way of reusing that block of code. So let's take a look at what a function is in terms of how we define it, how we create them. This is the so-called anatomy of a function, and we'll do this with a familiar example of converting temperatures, in this case from degrees Celsius to degrees Fahrenheit. So our function definition we can type in here starts with a keyword called def that indicates that we're defining a function. Then you give the name of the function. In this case, it's going to be Celsius to far, so we don't make you type out all of Fahrenheit here. And then you have some parentheses after the name of your function, and inside there you can then list what are called parameters. These are basically values that the function is going to use when you run the function. Now, just like a conditional statement or a for loop, you end the line here with the colon character, and when you press enter in the Jupyter notebook, you should see it automatically indents the text underneath there. So again, we have indentation to designate the lines that are part of our function definition. Now, what's going to also be somewhat different here and new with functions is that we now have this return statement. And this is going to tell that when someone uses the function, what is the value that should be given back to the user who calls the function. And here we're going to define that it should return 9 divided by 5 times temp plus 32. And this is our conversion factor to convert from Celsius to Fahrenheit. We take whatever value is specified for temperature, multiply by 9/5, and then add 32 to that to give us the temperature in Fahrenheit. And you can see this looks basically like what's shown in the image beneath here, that we have our def keyword, we have a return statement. So when someone calls this function, what they're going to get back if they call it with the value for temp, is they would get 9/5 times temp plus 32 as the value the function gives back. So I'm just going to run that cell by pressing Shift Enter. And then we can continue down a little bit further to calling our function and actually put the thing to use. Now, what we're going to do in this case is test our function using a known value. And for instance, here, it's something known that the temperature of 0 degrees Celsius, which is the freezing point of water in at sort of standard conditions, is equivalent to 32 degrees Fahrenheit. So when we do this conversion using our function, we should expect to see a freezing point that's equal to 32 Fahrenheit. So let's define a variable here called freezing point and say that that's equal to Celsius to far. And here, we're going to give our Celsius temperature as 0. So this is going to use our function with the temp value equal to 0 and assign what comes back from here, the return value, will be assigned to the variable freezing point. So if we just look back up here for a second, we're passing in a value for temp of 0. We're going to get 9/5 times temp. That's going to make that term 0 plus 32. And we're going to return this expression's output to the variable called freezing point in this case. So we should expect to see a value of 32 based on the equation we have here. So we run the cell, and then if we print out the freezing point of water in Fahrenheit is, you don't have to type all of this if you don't want to. You could just print out the value if you prefer, is freezing point. So here's our print statement. We'll just add some nice text here so we can see what's going on. But if we run this and whoops, somehow this cell got set to be raw. It should be a code cell. Perhaps that is going to be an issue with the notebook you're using as well. So sorry if you tried running this cell and you notice that it's not working properly. It does seem like maybe in the notebook version that, I don't know if maybe I just did this or if this is everybody's notebook, but you can check when you have this cell selected to make sure that the cell type is set to code. Otherwise, it isn't going to run this as Python code. But there we go. The freezing point of water in Fahrenheit is 32 as expected. We could do the same thing now with the boiling point of water. And in this case, the expected value is 212 Fahrenheit. So we could print out the boiling point of water in Fahrenheit is, and in this case, rather than using a variable, let's just call our function right in here as Celsius to far with now 100 for the temperature in Celsius. And again, if you run this cell, you see the boiling point of water in Fahrenheit is 212. Looks like our function is working as expected. And you can see perhaps already at this point that the reason for doing this is that this does make it easy to see. If you have named your function something nice like Celsius to far, it's probably quite clear to most users or most readers that you're converting temperature from Celsius to Fahrenheit, and that the temperature that's given here, the number that's given here, is a temperature. And so rather than having to put this kind of expression in on these lines, so instead of putting in 9 divided by 5 times temp plus 32 here, we have our single call to our function. And yes, here we have a relatively simple function that just returns a short expression and a single numerical value. But as your functions get a little bit bigger, maybe you have several lines, and you'll see that you're saving a lot of space and improving readability by just using the function call. All right, so at this point, let's make ourselves another function. And now we can create one called kelvins to Celsius, where we can calculate some temperature in kelvins to degrees Celsius. And here we can, again, start with our definition of our function with the def statement. Give it a name. As noted here, it should be kelvins to Celsius. And just to be clear in this case, we'll call our variable here, our parameter that we're defining for the value that would be passed in, temp kelvins. Now, we could definitely use temp just as well. There's nothing that says we have to use temp kelvins. There won't be any conflict if we use temp in the definition of the Celsius to FAR and then use temp again in the definition for Kelvin to Celsius. That's totally fine, but we'll just put it here as temp kelvins for the sake of clarity. What we'll do as well is we can provide, in this case, a default value. So if someone uses this kelvins to Celsius function without specifying a temperature, it will default to using a temperature of absolute 0. And depending on the kinds of functions you're using, you can think about it. Maybe it's useful to have a default value, or you can also have sometimes things like optional inputs that would have default values. So we've defined it here. Well, now we need to give a return statement, and we know that it's going to be, in this case, from kelvins to Celsius. It should be temp kelvins minus 273.15. Again, that's our conversion factor, as absolute 0 in kelvins is minus 273.15 in Celsius, and this sort of size of 1 Kelvin or 1 degree Celsius are the same. So we've defined our function here, and now we can again use it. Let's do it first here as defining absolute 0 in Celsius. So we can say absolute 0 equals kelvins to Celsius. And we could say here temp kelvins equals 0. You can add some spaces there if you like, just to make it more readable. So what's different here? Yes, we're calling our function again, just like we did before, but now we're specifically saying we want to define the variable or the parameter temp kelvins, which is part of the definition of the function here. So this parameter name should be one of them. It's in the definition of the function itself. We're saying temp kelvins equals 0 in this case. We run this, and if we print out our output, we can say that absolute 0 in degrees Celsius is, and then we should have our absolute 0 value. Why do we need a function at all if the parameter and the return value are already defined? I'm not totally sure that I follow the question here. I'll come back to that in just a second, and then we can talk about that. So yeah, so we have absolute 0 in degrees Celsius is minus 273.15 as we expect. And that's now working properly with our definition and use of the function here. We don't need to include this parameter name temp kelvins in here. So we could just say kelvins to Celsius with 0, and that will then fill in the value for temp kelvins when the function is used. So you don't necessarily need to list the name temp kelvins there. And if I run this, I get the same output. In fact, in this case, we don't need to give a parameter, value at all, because temp kelvins, if nothing is given, will default to being 0. So we can also run our function this way with nothing specified, because we have a default value, which makes this temp kelvins parameter actually, it makes it an optional input. So yes, okay, there's clarification of the question now in chat. So yeah, what this means is that you can think about these things when you define functions, that sometimes you have values that you must specify in order to use your function. Other times you say, okay, well, something could be an optional value. Personally, I think in this case, if I wrote this function and wanted to use it, I would probably not include a default value here. Reason being that if someone's using this function and they don't give me a temperature that should be converted, I think I prefer the case that you're going to get an error message instead of using a default value, because defaulting to absolute zero doesn't necessarily make sense for converting a temperature value. So if we define the function again, this way I'm just going to run the cell and redefine our Kelvins to Celsius function without giving the equals 0 here. Now if I call the function without specifying a parameter, I get a type error that says it's missing one required positional argument. There's maybe a comment or someone's microphone got unmuted. Oh, maybe it's okay. At least I was hearing something. So anyway, here in this case, I've just taken away this default value of being equal to 0. And now if you try to use this function without specifying a temperature to convert, you instead get this error message saying that you're missing an argument, you're missing a value that should be specified for the temperature. In terms of a programming approach, I think actually that's a better way to do it for this particular function. The reason that we show you the default value, of course, is just to show you that you can use these default values, but you should also think if something is an optional output, it's truly optional, then using a default value makes sense. If it's not an optional thing, like I don't really think using this function without specifying a temperature is an option. So if you want to use my temp Kelvins function, you should give me some temperature, like whatever, 400 Kelvins, so that when I run the function and print out the output, I can now see what that temperature is. Okay, it's no longer absolute 0, but you can see the point here that you can specify the temperature value here. If you specify nothing, it should error out, in my opinion, because that's it doesn't make sense to have a default value. But you could also, just for clarity, say temp Kelvins equals 0 or whatever, 100, whatever you want to put in there. So you can specify it either with the name of the parameter equals to some number or just by the number itself, and this will work. I hope that didn't confuse you, but I just want to make the point about these, the difference between having a default value and not having a default value for a function, because if we didn't, like if we have a default value here, potentially this temperature conversion could be used without a value being specified and cause problems later on in our program. All right, now it's time for me to stop talking and for you to start, well, I hope you're already thinking, but you can dedicate some thought at this point to a little check your understanding activity here. So we can check in, see how things are going with the function. And we're asking you to create a new function here called hello with 2 parameters. The first parameter should be called name, and you should assign some text to that parameter when you use the function. The second parameter should be called age. So we had been doing examples here where we listed a single parameter, but you could put comma here and then say, define some other value here. So whatever, some other parameter value, whatever, b equals something, or whatever text you want to have here. If you want to define a second parameter, you just have a comma and then you list another parameter name within the definition of your function. So you can define a function called hello with name and age as the 2 values. When you call the function, you should define name and age to use it. And it should operate in such a way that when you return the value, so let's say you say output equals hello with your name and age defined there, you assign it to your variable called output. And if you do print output, you should get something that looks like, hello, my name is Dave, I am 39 years old, and this is actually let's be honest. I'm 40 years old now, so I hadn't updated that cell since we did the exercise last year. Anyway, you can run this and say, hello, my name is your name. You are so many years old. You can be honest or lie about it. It doesn't really make any difference, but it's mostly just for you to practice. We're going to take a look at our participants list here. It looks like Vocal has already cleared out the check marks. So once you have done this exercise and you've managed to print out the output that we expect to see here, you can put a green check mark, and once we get a sufficient number of green check marks, we'll continue from there. Okay, maybe we should continue on at this point. So I'm sorry for those of you who are trying to get this working. You can always I don't know, close your eyes or something while we go through this. And then if you don't want to spoil the surprise, I don't think I'll necessarily give it away with what I'm saying here, but I guess you could also mute your microphone or mute your speakers or whatever, headphones, if you like. So the task here was to print out this statement, hello, my name is name, and I am so many years old, where name and the age that you are should be specified when the function is called. So we can start with our definition of the function, with our def parameter, or def statement rather, and we're going to call our function hello. And as noted here, it should take name and age as input values. And we're not going to put any defaults to these. We'll just say that there's a parameter called name and a parameter called age. Within our function, we're going to return a character string, because what we want to do is when someone calls the hello function, we want to say that it assigns this character string to whatever variable they use, or just prints it to the screen if they're printing it using the function call. So we're going to return a character string that says something like this: hello, my name is, and then here we're going to give our value of name. And this is fine because name would be expected to be a character string in this case. So hello, my name is name. And actually, let's do it like this. My name is, and I'll add a space here, and then we'll do a plus name. This way we can control the spacing a little bit. And then plus here. So the name would be the name itself. So far we have hello, my name is, with the space there. And we're going to fill in the value, for the variable name will be replaced with whatever name you have here. The next thing then after that is going to be period, and then space I am. And then another space. Now we're going to have our age here, but remember that age is going to be a numerical value, and if we're adding together different pieces of a character string, we need to convert that to being a character string as well, using the str, the string function that will convert a number to a character string. So then we have the number there, so we should then have, after that, space, years, old, period. So hello, my name is name. I am number converted to a string, years old. That should be all we need to do as far as getting our function to do something. And I'll just add another cell underneath here because we've defined our function. And of course, we could do this in the same cell, but I'll just put this in a separate cell that we could say output equals hello. And then we could say Dave, and then the number 40. The assumption here is that age is going to be given as a numerical value. And if I define that, then I would want to print my output at that stage. So I've defined this character string here to a variable called output, then I want to print it. And as expected, we see here, hello, my name is Dave. I am 40 years old. We could also say that my name equals that and my age equals that if we wanted to give the parameter names. And actually, that's not a bad approach when you have multiple parameters, just to be totally clear for what you're defining. In this case, I think it actually doesn't then matter which order they're given in. I could be wrong, but I believe that's the case, yeah. That when you have doing the assignment using the parameter name, you can then list them in whatever order you like. So sometimes when you have functions that have several parameters, you might not remember the order they were given in, and you can then change up the order that way. Okay, so that's how things work for that example, and hopefully if there are any questions about that, you can put them in chat and we can discuss those. But otherwise, we're going to move on to our next next example here of a function. And in this case, we're going to define a function that will allow us to convert kelvins to Fahrenheit. So already we have a function to do Celsius to Fahrenheit, and we have a function to do kelvins to Celsius. So the kelvins to Fahrenheit is going to complete the loop in a sense, allowing us to specify a temperature in kelvins and get directly a temperature in Fahrenheit from that. We're going to do this, though, using a little bit different approach because we already have functions to do the conversions to go kelvins to Celsius and Celsius to Fahrenheit. Let's use those functions inside of our new function called kelvins to Far. So again, let's define a function. We'll start out by giving it the name kelvins to Far, F-A-H-R. Again, what we should be having as an input here is a temperature, and we can call it temp kelvins. Again, just because it is a Kelvin temperature, or temperature in kelvins that should be input. Now in this case, we're going to do a couple steps. So we're going to have more than one line. We're not just going to immediately return a value here. What we're going to do first is within our function, we're going to define a variable called temp Celsius. And our temp Celsius variable is going to be equal to our conversion when we do kelvins to Celsius using our earlier function we defined. So as you remember earlier up in the code, we defined this function called kelvins to Celsius. It's still stored in the memory of this notebook when we're using it down here. So then we can do kelvins to Celsius with temp kelvins as the value that's going to be converted. That's going to give us a temperature in Celsius. After that, we can then do temp Far, our Fahrenheit temperature, as being equal to our temp Celsius being converted now to Fahrenheit using our Celsius to Far function. So now we do Celsius to Far with temp now Celsius in here as the value that's being converted, because we just defined that on the previous line of the function when converting the temperature in kelvins to Celsius. Then we take our Celsius temperature and convert that to Fahrenheit. And finally, we can return temp Far. So strictly speaking, we could have returned this value directly, like return the call to the Celsius to Far function. Doing it in this way adds an extra line to the function, but it comes along with the benefit that this is maybe a bit more clear of what's happening. We're converting to Celsius, then we're converting to Fahrenheit, and in the end, we're returning the Fahrenheit temperature. Now, if I run this cell, we've now defined our function to do Kelvin to Celsius. And so what we can do now is define a value here for absolute zero again. But let's call it absolute zero FAHR for our absolute zero value in Fahrenheit. And this is now going to be using our kelvins to Far function with the value of 0 as the temperature that's going to be converted. And if we run that, we're going to define this value for absolute 0 in Fahrenheit. And of course, then we should print that out to see what value we have. So absolute 0 in degrees Fahrenheit is, oops. And this would be our absolute 0 FAHR. So this should take the value that we've calculated as absolute 0 using our function kelvins to Fahrenheit with 0 kelvins temperature and print that out now to the screen. And so we can see absolute 0 in degrees Fahrenheit is minus 459.669, blah, 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 blah. I think that's the right number. I don't know for sure. Probably if we wanted to convert our temperature to Fahrenheit from a Kelvin value that is known, we could put in something different here. So we could, for instance, say 273.15 as our Kelvin temperature to convert. 273.15 is the temperature of water freezing, so 0 degrees Celsius, which should be 32 degrees Fahrenheit. And if we run this again, okay, I haven't changed the name of absolute 0 far for this demonstration, but now we can see absolute 0 in degrees Fahrenheit is 32, as we would expect. So it's good to check and make sure that the function is working the way that we expect it to, and this one gets the stamp of approval in this instance. All right, at this point, we are probably a little bit past the time when we would normally take a break, so we should do that. Are there any last questions about this introductory stuff on functions at this point? We've gone through a few examples, and we'll get more practice with functions, of course, in the exercise for this week. But you'll see that I think my perception is that that the things that seem to cause the most challenge in the beginning here in the Geo-Python course are the loops and the functions, because they just are a little bit, take kind of maybe a bit of practice to get used to using. Hopefully you can see the value in using the functions, because obviously being able to just have this single thing, a call to a function to do this conversion rather than having several lines of code is very useful by itself. Not to mention the fact that you don't have to copy paste this piece over and over. You can just call the function one time. Or if you had a code that used that same function 200 times, you just change the definition of the function once, and then all 200 of the calls to the function will be then affected by that change. All right, well, it's time for a break, and maybe we should take 10 minutes, and by my watch, that would have us returning basically at 10:50. So we'll come back and continue in 10 minutes.